Welcome back. This is our first lecture on Introduction to Big Data, where we'll discuss what big data is in detail, and also conclude with differentiating what is data science and business intelligence. Okay, so I like this infograph. It's a word cloud. Well, it's very feature rich. If you look at big data, you can see different things emerging here. We're talking about storage. In a few slides, we'll see some of the characteristics of big data. All right, it's voluminous, large scale data. So we're talking about storage. How do we store this data? All right. We'll talk about analytics processing. How do we process this big data? We also recognize that big data can be very complex, due to its very voluminous nature. Okay, see, it's coming from different sources. Social, we talk about census. Okay, again, here is where we all belong, practitioners. This is a challenge in the industry. There's still a high demand and very low supply. Okay, again, how do we capture this big data? All right, we talk about petabytes of data. So this is really good. But again, the end goal here is how do we derive value out of big data? Okay, you can see big data is kind of scattered in a way. Then we need to transform, process using some analytics, and organize this data so that we can make decision. And this decision should, provide us some value. It could be a dollar amount. Okay. All right. Let's look at the agenda. We'll talk about what big data is, characteristics of big data, hierarchy of data, types of data, levels of measurement. What are some of the sources of big data? What are big data challenges, tools for big data, then conclude with an infograph, how to differentiate, what's the difference between business intelligence and data science. Okay. So what is big data really, right? This is a buzzword. It's been with us for many years. In fact, Google came up with this term. Let me just take you there. So if you look at early 2000, this is the term that was coined by this guy, Roger Margolis, right? Who described it as large set of data. Okay. And over time, this was kind of integrated with Hadoop. Actually, was integrated with Hadoop and Google's MapReduce, but that's our last topic. Yeah, so Google, played a big role in advancing this terminology. Again, by definition, we describe big data as massive volume of both structured and unstructured data. Okay, that cannot be managed or supported by traditional techniques, right? So if you look at this infographic, you can see how do we store this data. All right, data is coming from different sources, satellite images, right? It's coming from sensor data. Okay, how do we visualize this data, this big data? Okay, how do we transform this data? Okay, data is coming from across the globe. Okay, how do we ensure that this data is accurate and precise? Okay, how do we secure our documents? See, we have key encryption and privacy and security. How do we search this data? Okay, all these are different challenges that we need to address. How do we configure this data? How do we derive value, okay, from our data? How do we, establish connections in our data? When we talk about social networks, we talk about all these graphs. We talk about these connections. Okay. All right. So really, to describe big data, you need to really look at the different V's of data. Now, next slide, we'll look at that. The first one is volume. We talk about large amounts of data. When you hear the term big data, think about the large volumes of data. And when you talk about large volumes of data, we talk about zettabytes or petabytes, right? Okay, and it's collected from different sources. Okay, mostly from digital interaction, like social media. In fact, the sources of big data summarized by this infograph. There's a whole slide dedicated for that, but you can see from social media to mobile sensors smart grids, all the way to medical imaging and gene sequencing. All these just generate tons and tons of data, okay, that contribute to some of the challenges of how to manage this data, right? And if you're talking about mobile sensors, they come in, at a high rate of velocity, great speed, and that's one of the other V's of big data. Okay, so that's another way of looking at it. But let's just look at this in perspective. So most times, this trend has been changing over time. We talked about 3 V's of data. Now it's 5 V's. We have 7 V's, 9 V's. But when describing that, I think just keep it simple. The 5 V's of data. We talk about the scale of data, right? The sheer amounts of volume. Right now, we have over 6 billions of people on planet Earth, right, who have cell phones. That alone just generates tons and tons of data, right? Most organizations, like maybe Fortune 500, they keep hundreds of terabytes, each one of them, right? So, and this keeps on increasing over time. We talk about 40 zettabytes of data by 2020. By now, I think it keeps on just changing. Okay. When we talk about velocity, right, data is coming at speed. All right. We're talking about connections of data. When you look at self-driving vehicles right now, they have tons and tons of sensors, and these sensors keep on sending data at almost in real time, right? So we talk about this streaming data that's coming in very fast and in large volume. Okay. Then also we talk about variety. Variety here means we have data coming in different forms. Okay. When we look at social media, we talk about images, we talk about videos, we talk about text on Twitter, right? Facebook here. And all these are just generated by one platform. Okay. And then again, we look at veracity. This is another challenge when collecting or capturing big data. How accurate is your big data? When you talk about GIGO, garbage in, garbage out, the kind of input, and that's why our next topic will look at data preprocessing. It takes so much time, like 50 to 70% of the time, trying to prepare data to be accurate, removing all those anomalies, missing data, missing values, right? Just to ensure that there are no discrepancies in your data, right? So that, once you collect that input, once you start visualizing the data, you can have some accurate depiction of your data, organization data. And lastly here, after we apply some analytics, right? Okay, we want to make some decisions. So this big data should give us value, should provide us with value, right? This value could be in terms of dollar revenue, or can help us make those decisions that can increase our revenue or reduce our bottom line expenses. And that for you is big data, okay, in terms of characteristics of big data. Okay. This is another infographic. As you can see, 7 Ds of data in addition to what we've looked at. You can see we have visualization. This is another challenge. How do we, try to reduce all that big data into some graphs, that are manageable and readable and accessible. We live in the pandemic era, and we can see we want to look at one visualization that shows us, what's happening, probably at state level or country level, in terms of COVID-19, right? Variability, that means data keeps on changing constantly. Okay. Moving on. Another thing I just wanted to pay you to highlight here is the hierarchy of data. Some of you might already be familiar with this. At the bottom level here, you can see data exists in zeros and ones, right? And a group of 8 bytes or 8 bits make a byte, right? So in ASCII, we can represent the letter F just by combination of these bits and bytes, okay? And then a collection of fields, a collection of characters is what make a field. For example, your last name field or your first name, right? In our case, you can plug in your name here. Then when we have a collection of related fields, then that makes up a record. right? You can see now all these are just combination of different fields, okay? That could contain your social security number, first name and last name, hire date, and all that. And then once we have hundreds or tens of records, right? Think about this when we look at a table which has rows and columns. Okay, so rows will be the records, fields will be the columns, right? So a collection of related records constitute or comprise a file. All right, and we can now say that's a personnel file, including records of all employees, for example. Then when we have a collection of related files, all these make up a database, right? That's why in a database, you can have the personnel file, department file, payroll file, all these are kind of interrelated. And that's the hierarchy of data, okay? Moving on, types of data structures, very important. Most times when you look at big data, you'll come across these terms here. So at the bottom here of the pyramid, this is an inverted pyramid, just to show you the complexity, right? As you increase upwards, the data exponentially increases, right? From structured to unstructured. Really here, most of our data exists as structured. Most databases that we know today are called relational databases because they form, you can store data in form of rows and columns, right? But now with what's happening now with big data, right? As you go up, we have semi-structured data. What that means, we have textual data, right? If you've ever used XML files, you might have come across this, or JSON file, meaning you can, it's a bit flexible. Here is kind of schema dependent. Here is schemaless. You can define your own schema. Then when you talk about quasi-structured data, this is data better known as streaming data. Okay, the data is kind of erratic. The format is erratic. Okay, but mostly we'll come across structured, semi-structured, and unstructured. Unstructured is what we know today as social media. There are a lot of text documents, PDF, images, and videos. All this you might not store in a traditional database. So most times we store this in NoSQL databases, right? And again, this is what we talk about when we talk a bit about big data. One of the challenges of capturing and processing this data. Okay. All right. So let's look at now the levels of measurements. So when we look at the levels of measurements, it's important to understand that there are 4 categories measurements for a variable. Okay. But what's a variable here? So a variable here could be defined as a quantity that can be measured and whose value varies with a population. Okay. So let's first of all look at the nominal. So when we talk about the nominal variable, we talk about non-numeric. But before I talk about this, we can actually categorize this either as qualitative measures or quantitative measures, right? Qualitative means categorical, it's textual in nature. And these 2 measurements belong there. Then quantitative, we're dealing with numeric, okay? We can talk about interval measures and ratio measures. So nominal here, some of the properties we're talking about here is non-numeric and cannot be ranked, right? We cannot perform any quantitative measures here. Okay, examples include probably gender, marital status, ethnicity, and things of that nature. And you can see here, you can do some frequencies and all that and visualize that based on this graph. Okay, the second level of measurement is ordinal. And remember, all these kind of feed on each other. As you go down here, as you increase from qualitative to quantitative, each of these kind of just picks up the characteristic of the previous levels of measurement. So in ordinal, we talk about, the categories actually ordered, okay? And we don't have equivalent distance between the categories, right? What that means, for example, when we talk about a class variable for a person, right? We could talk about income or where you live. It could be upper class, lower class, or middle class, right? Okay, so you can belong in each of these, either one of these category, right? Another example be grade, A plus, A, B, B plus, just helps us to, help with the ranking, right? But any distance between it, between these intervals, right, is meaningless, right? Also the quality here, or this designation, okay? So we can only measure that based on the order. Ranking is very important, the logical order. Then we look at interval. This also, not only is it named variable, it's also ordered. At the same time, there is some now meaning between the intervals, right? Meaning there's equivalent distance between categories here, right? So when you talk about temperature here, right, talk about GRE score. A good example would be, for example, if you go and shop or look at the shoe size, right? Talk about the difference between maybe a shoe size of 3 and shoe size of 4, right? Okay, there's an equal distance between that. It's the same equal distance if we look at a shoe size that is 10 and a shoe size that is 11. There's an equal distance of 1, right? But you cannot say that a shoe size of 6, it's not the same as saying it's twice the shoe size of 3. Okay, but at the same time, when we have a shoe size of 0, it does not mean that there's no shoe. Okay, what that means is that simply a shoe with a 0 size. Okay, so here we talk about an arbitrary 0 point. Okay, and lastly here we talk about ratio numbers, right? This one includes all the characteristics of the previous 3 levels. The only additional thing here is that it has a meaningful 0. Okay, an absolute 0, right? Okay. So we talk about when you say a weight of 0. Okay, we talk about age, talk about height. You can say, if somebody is 50 kg and another one is 100 kg, you can say actually the person who is 100 kg is twice the weight of the person who is 50 kg, because there's actually an absolute reference point of 0. Okay, so this is very important. And in fact, another thing to keep in mind is that with ratio, you can now do mean and median, okay, and standard deviation, which was absent as part of the descriptive statistics for all the others. Okay. All right. And lastly here, as you move from nominal measures to ratio measures, you can see the analytical power increases, right? Not only that, but also the complexity. Okay, complexity of not only the statistics involved, visualization, but also the complexity of the variables involved, right? You're dealing with more variables, and the complexity of the data also increases. Something that's just to keep in mind. All right, that's it for levels of measurement. And then when we look at sources of big data, right? Again, this graph here, or infograph, summarizes all the different sources of big data, or some of the big sources of big data. We talk about satellite imagery, accounting systems, as part of ERP systems. Social media, all of us belong to some social media platforms, Facebook, Twitter, we talk about Pinterest, YouTube. All this generate tons and tons of voluminous amounts of data, whether it's images, whether it's Instagram for images, we talk about video, and so on and so forth. Okay, such engines also generate or store humongous amounts of data. Okay, we talk about personal devices. We have our laptops, smart books, and iPads, mobile phones. All these generate gigabytes of data, if not terabytes. Okay, talk about smart devices, products, scanner, telematic devices for those people, for those professionals in the field. They collect a lot of this data, right? Environmental monitors, right? Talk about smart thermostats and whatnot. So cumulatively, we can say that all these sources of data, is just information about people, comes from places, and just about anything, a lot of things, right? It could be at the state level, location or activity based, like, your wearables, right? You collect a lot of data, if you're sleeping, if you're eating, or if you're walking, running, just your from your active, uh, uh, smartwatches, for example. Okay. All right. So now let's move on to another good example here, just to show you, just to build up on that. So in 2018, this just shows you how, uh, in 1 minute, right? YouTube generated like 4.1 million videos, right? Facebook, over 900,000 logins, right? On Google search engine, very popular search engine, there were over 3 million search queries. Netflix, over 17,000 hours of videos was watched and all that. So really, you can see how just in 1 minute, how much data is being generated, and we need to figure out how to capture this, analyze this data, um, visualize this data, and make sense out of this data. Okay. And this is just a representation of the big data we are dealing with in this day and age. Around 2020, you can see also there's been an increase. So overall here, we're trying to say that over and over, this big data, the trajectory is, as the year, as we move forward, there will be large volumes of data, moving from petabytes, terabytes to petabytes, and so it's just crazy amounts of data, and that's why we need to figure out some of the tools and techniques to sort of manage and visualize this data. Okay. Some of the big data challenges, right? We talk about this. Okay. All right. Again, you can see here lack of expertise. There's a huge demand for data scientists, data analysts, but there isn't much practitioners, right? So security and privacy, kind of really stretches some of the different mechanisms that we have in place. Every now and then, every year, we hear how some data has been leaked online and all that. So it's still a moving target, right? If you ask me. Okay. Issues in scaling up. How do we make advances? Maybe in hardware advances and software advances to sort of manage these voluminous amounts of data. Okay. In the real world, the data is actually poor. So how do we increase the quality of this data? So more data preprocessing techniques need to be put in, right? Okay. And also it's very expensive. It's very expensive to, from collecting this data. In fact, let's look at some of the, if you look here, the life cycle of data science life cycle, all these are very expensive processes, right? How do we capture this data? How do we process this data? Maintenance in the data warehouses. How do we analyze, right? And how do we communicate this data? It's a very heavy, intensive and expensive process. Okay. And then also data, how do we capture data that's streaming in real time? Okay. This can present a huge challenge. Okay. And so on and so forth. There's so much rationale on why, we need to develop advanced or newer tools and techniques to sort of address these big data challenges, right? Okay. And then as we conclude here, so what are some of the tools and technologies for big data analytics, right? So this just gives you a snapshot or summary. So from a domain perspective, statistical analysis and data mining, we're going to be using R, right? As you can see here, and Weka, but really we have all other libraries like NumPy, SciPy for mathematical calculation, Mahout, Hadoop for machine learning. And again, it's kind of differentiated by open source and commercial. We used MATLAB, SPSS, and Starter, or SAS, all those are commercial software. Then we have analytical framework and NoSQL. Again, these are just storage, mechanism or platforms like MongoDB, very well known, allows you to store document-based big data. Okay. When we talk about natural language processing, we have different libraries that can help you to a very famous library is NLTK, provided by Python, allows you to sort of process and provide some analytics for that. And then lastly here, visual analytics, we have Gephi, Matplotlib. We also have, we have ggplot in R, and also from a commercial perspective, we have Tableau and Power BI. Okay. All right, that's it. The next slide here. But before we look at some of the differences here, let's now define what business intelligence and data science, what that is, right? So by definition, we could say that data science is essentially the ability to take big data or capture big data, understand it, process it, and extract value from it, visualize it, and communicate. Okay. This is a very important skill to acquire, and really that's big data. Okay. And some of the tools we've already talked about, we're going to be learning are, but others include Python, for storage databases. NoSQL, we have Apache, Hadoop, that's a whole architecture system. Okay. Tableau for visualization. GitHub, it's a platform for developers and data scientists. Allows you to do a lot of commit and maintaining your code and everything. And it's open source. Okay. On the other hand, when we look at BI, right? So we can define BI as, so where is this? So BI could be defined as it combines business analytics, data mining, data visualization, data tools, and infrastructure that provide best practices to organizations that allows them to make more data-driven decisions, right? Most times, you'll find that if you have ever used an ERP, BI is a very important component that sits at the top of the data warehouse, right? This is what powers the, you're dealing with historical data. Okay. Now that we know the definition for this, let's look at the differences, right? So in terms of perspective, right, you're looking at the past, okay, and the present. So maybe you're looking at a 5-year trend or 10-year-old data, historical data to determine the present. But with data science, you want to predict. In fact, this is descriptive analytics, and this is predictive analytics. In terms of data types, data science, we are looking at collecting both structured and unstructured data types here. We're dealing with structured data, relational databases, right? Deliverables here for business intelligence, we have dashboards, ad hoc requests. Data science, we're looking at statistical and predictive models, right? We're performing hypothesis testing. Okay. A business value here. Here we want to drive decisions. Here we want to provide some strategic planning, right? And that's it. And then lastly here, I welcome you to visit this. Already I've shared this with you, but it's just the data and AI landscape just gives you one of the things that we've already mentioned here. What are some of the tools and techniques that allows us to manage big data, right? You can see from visualization perspective, we have Tableau, Power BI. We talk about data science notebooks. We're going to be using Google Colab. We talk about NoSQL database. We have MongoDB, storage here, platforms. In fact, if I zoom in like that, storage platforms. We talk about Amazon S3, Google Cloud. Okay, but really will be our emphasis will be on open source, right? And more importantly, we'll be looking at statistical tools and languages. We have R here, Python, and so on and so forth. Okay, so please take a minute or take a few minutes just to look at, some of the open source tools that are available to us, in order to manage some of this big data. Okay. All right, and that concludes this introductory lecture on big data. Okay. All right, thank you.